Okay, so project 6. We started with an initial idea, kind of a video we found online, and took that and really used the same materials that they did and built that right away. And it worked, but didn't go as far as we needed it to. So I think evolution-wise, we added more rubber bands to make the spring harder, so it would launch the gummy farther. Kind of more glue than they said we would need, and a couple other things. But really, it didn't change that much because it worked very well right when we built it.
So some of the pictures that we took, we obviously took a picture of ours, we took a picture of Brandon's, and of Amel's and Caitlin's, and they're all really different from each other. Like, we used popsicle sticks, Brandon used pencils to, like, build the actual structure. Caitlin and Amel used giant pieces of boards that wood. Wood, like that they got at Home Depot. But we used popsicle sticks and rubber bands and glue.
And and like all of these were all really effective. Brandon's worked in like the second try. Ours was probably third try.
Yeah.
Caitlin and Mel's took longer, just because they weren't really accurate with it, but it worked every time. So I think, we kind of saw that like all 3 designs were very different, but very much effective in kind of how far it would go and just the accuracy of it.
So if we had to change our design, I think we'd probably, like, the general idea, like, of our design, like, was really effective, and, like, we wouldn't have to make, like, a lot of changes, but, like, if we were to make changes, we'd probably make it a little heavier somehow, like, put weights on the bottom, because we had to, like, hold it, like, one of us had to hold it, and the other person had to pull the arm back and launch it. Just, like, a little light. Yeah. That's because it was made out of popsicle sticks.
Yeah, and the popsicle sticks worked great, but they were also a little bit flimsier. So on that first day we were testing before break, the first time I launched it, the side just kind of snapped off because the popsicle sticks wouldn't hold with the glue. So just added more hot glue and then put rubber bands around the base, which worked really well. So I think the structure of it was effective, but again, some of the little details about, like the weight and like the popsicle sticks. So maybe we should get our catapult. So, but everything else I think worked really well. Here's our baby right here. So we added more glue and rubber bands
on the base.
Yeah, just to hold it. But again, we had to hold it down when we were launching it, or else it would have
exploded.
Gone forward. What's forward right here?
Okay, so project 9. Concept is momentum and energy. We basically, like, the entire concept of a catapult, it uses, like, both, like, energy and momentum. For the energy part, like, there's potential energy in, like, the actual, like, cradle part, like, while it's, like, at rest. There's potential energy while it's, like, moving through the air because it has height. And there's kinetic energy, like, also when it's moving through the air because it's moving. Momentum. Conservation of momentum. It basically, like, momentum is always conserved in this experiment. First, like, it starts out in, like, the handle of the catapult, like, while it's, like the action of us, like, pulling back the catapult. Yeah. And then that momentum is transferred into, like, the gumdrop, and it's, like, moving through the air, and then it, like, finally, like, lands, like, on the ground. So, for conservation of energy, like, energy starts out, like, in the rubber bands that we're using to launch the actual catapult, and then, like, like, the same as momentum, it moves into the gumdrop, and it keeps going till it hits the ground.
Project 10 was how did you grow from this project? Definitely my creativity skills really just were shown in this project. Yeah. No, but I think that, like, it changed my ideas about the catapult, because I think when we built it, I was nervous that it would not go so far just because of its, like, size of the base and stuff, and then seeing other people's and, like, how big they were and how, how far they were going to go and whatever. But so I think I grew, I guess, just in my knowledge of that, and just how it's more, our power was in our rubber bands, whereas other people, had huge bases, but really only had one, one string or one pulley kind of acting as the, like, launch for that. How would you improve this? I don't know. Ours worked pretty well.
Yeah.
So.
We got in the target.
Yeah. What were the things you learned? Yeah, and gain. Again, just kind of the differences that you can have. Yeah, you gotta talk here.
So, like, the same thing that Lauren said, growing from this project, the creativity part. But not only that, like, I feel like we both, like, had, like, a deeper understanding of, like, the actual, like, science part of this, where, like, you need, like, a certain amount of energy to, like, launch the gumdrop. Like, I pulled it back, like, really far, and it, like, went too far, and then I pulled it back, like, relatively not as far, and then didn't go anywhere. So we just had to, like, find that, like, one specific thing. We probably could have, like, calculated that with numbers, but we, like, got to physically, like, do it instead.
Project 11 was the mini experiment, so we put it on an incline, which was what, like 3.5 centimeters tall. It was a biology book. And it was kind of all over the place when we tested it. Initially it went shorter than 10 meters.
It was like 7.3 meters.
Because when you launched it, it went, like, higher. And then another time it, like, went high but then farther, so it kind of differed, again, just based on how far you pulled, which was the same case even if it was not on an incline. But I think what caused these outcomes was definitely on an incline. It changes the angle of the launch, so it's landing back farther, again, putting it up more instead of throwing it straight forward. I think if you did it on wheels, a lot of people tested it and it didn't work kind of how they thought it would. But again, that was most likely going to throw the gumdrop, like, not as far because the launch of it would push it backwards. So there's just different, we didn't really see anyone else using the wheels, but everyone who was on an incline seemed to go shorter.
Yeah.
Just because of the change in the angle.
Project 12, yes, we've turned it in on time. Both of us, like, obviously had, like, an active role in the, like, making and, like, the general launching of the thing, except for I wasn't here for, like, the...
We didn't really miss anything that day. We just kind of tested it, and I had to, like, re-glue some things.
So we were both here for, like, building it, and we're both here for, like, the actual launch date. We're here now. We'll be here next class.
Woo! Catapult!